Finding alternatives for petrochemical resources is of great interest. Petrochemical resources are exhaustible, so available amounts keep diminishing. Not only the production of fossil fuels is dependent on fossil resources, the chemical industry also highly relies on petrochemicals as bulk chemicals. Moreover, the use of non-renewable resources results in the emission of the greenhouse gases like CO2, methane, and carbon monoxide. The replacement of petrochemical resources will therefore be necessary in the near future. An alternative resource could be biomass. Biomass is a renewable energy source. It is mainly obtained from plant waste products that are considered as industrial byproducts, such as corn fiber and wheat straw, whereas the sugar-rich components are used for other applications. This plant waste biomass can be used for the production of biochemicals and bioethanol for the food, feed, and non-food industry. Lignocellulose biomass is the most abundant renewable resource present, also it does not compete with the food crops, as only the non-edible components are used. The plant cell wall is built of three major components: cellulose, hemicellulose, and lignin. Cellulose and hemicellulose are polysaccharides. Lignin is a polyphenolic compound. These three components are linked covalently via cross-linkages and non-covalent forces, making the cell wall recalcitrant to cell wall degradation. One of the three main components of the plant cell wall is lignin. It's a polyphenolic compound and has an amorphous structure. Lignin gives rigidity to the plant cell wall and protects the plant from microbial degradation of the polysaccharides. The structure originates from polymerization via hydrogenation of p-coumaryl, conferenyl, and synopyl alcohols. Lignin contains three phenylpropane monomers as seen here. These compounds differ from each other in their degree of methoxylation. They are joined via carbon atoms and either bonds and form via radical-based lignin synthesis a complex three-dimensional structure, making it a heterogeneous and complex compound. The cross-linking of lignin with other biopolymers as cellulose and hemicellulose results in a complex assemblage of macromolecules. This challenges the usage of lignocellulosic biomass. The main linkages, the valorization of cellulose and hemicellulose have been highly studied to obtain biochemicals from them. However, commercial processes from lignin are not as advanced yet. Products obtained from lignin can be divided into three categories: power or fuels, macromolecules, and aromatics. The later one are of higher economic value and therefore profitable to produce. The challenge of using lignin are the many cross-linkages present in lignin and the varying structures that lignin can have.